Okay, so today's question is jump game 4. So it is an hard mark question. Given an array of integers ARR, you are initially positions at the first index of the array. Okay, we are positioned here. So in one steps you can jump from index I to index I plus 1, where I plus 1 should be below the length of the ARR, and I minus 1 should be greater than or equal to 0, and j where ARR of I is equal to ARR of j. Suppose so this is 100, so we can jump to other 100. Okay, and both I and j should not be equal, means they should not be the same value or same index. So we have to return the minimum number of steps to reach the last index of the array. Notice you cannot jump outside of the array at any time. Okay, so what we will do, we will try to use BFS algorithm for this. Uh, we will make this index or each element behave as they are the node of a particular graph. So let's try to code this. So first we will take the length, so n is equal to len of ARR. Okay, and what we will do, we will create a dictionary which will store the indices of the values which are same. Okay, at what all indices the value are same. So for that, let's import default dictionary. So from collections, import default dict. So what we will do, we can define our dictionary as dict1. Okay, now simply enumerate through ARR. So for I comma val in enumerate ARR dict1 of val dot append dict1 of val dot append I. So here we have to set dict1 as the default dict of dictionary. So default dict of list. Okay, so now it is a dictionary which contains list. Okay, so for I comma val in enumerate ARR default dict1 of val dot append I. So now this dictionary store all the values which are all the index of the value which are same. Suppose for 100 it will be storing 0 1 2 3 4, so 0 and 4, and similarly for the 400 for their indices. So yeah, we have done with. Now what we'll do, we will use a BFS algorithm and we go level wise. So if at any particular level n minus 1 is there, that means that is the number of steps we should take. Okay, so for this we will be using the dq. So let's import that. We'll be using dq or the q. So now define dq. So q is equal to dq and pass the first index. Okay, 0. Okay, and we will create a visited list which will mark each node as visited once we visit that. So we don't visit it again. So visited is equal to initially or a false, and we are starting from 0, so we can mark 0 index as visited. So visited of 0 is equal to true, and at first level of the BFS this number of steps will be 0. Okay, now we will simply do the BFS algorithm. So while q. Okay, so we will go till the length of q. Okay, we will pop out all the element of all the q. Okay, so I is equal to q dot pop left because it is q, first come first out. Okay, so I is equal to q dot pop left. So suppose if I is equal to n minus 1, that means we have placed the last index at the just the first of at the first level only. So we can simply return number of steps. Else what we can do, we can check which all are the neighbor of this particular index. So we can define a list neighbor. Okay, currently it is empty. So check if I plus 1, if I minus 1 is greater than or equal to 0, that means it's a valid neighbor. So we can simply append that. So neighbor dot append I. Similarly we can check if I plus 1 is less than n, means that's a valid neighbor. So we can append this too. So neighbor dot append I. Okay, and who else can be the neighbors? Now this indexes which have the same value also can be the neighbor. So what we will do, we'll simply extend this neighbor list. So neighbor dot extend, and extend with which, so d what is our dictionary name, dict1 of arr of I. Okay, so all the element, all the index which are in the this dictionary means have the same value, so they also can be the neighbor of this particular index. Now we will simply go through each neighbor. So for neighbor in neighbors, for neighbor in neighbor, okay, if not visited, if they are marked as not visited, if not visited of neighbor, so we will mark them as visited. So visited of neighbor is equal to true. Okay, and we will append this particular neighbor in our queue. So queue dot append neighbor. Okay, and okay, so that's create our this VFS algorithm. And finally we can, at each steps, at each level, what we can do, we can increase the steps by 1. Okay, and finally we can return -1 if we still don't reach to the neighbor. That means it's not reachable. Okay, other, if it is reachable, the first where we reach, that will be the minimum number of steps, as we are going level by level. So at any level, if we get n-1, that will be the shortest path to reach that. So let's try to run and check if this works. Okay, invalid syntax, did you mean not, where we have missed any typo mistake or something? Yeah, we have written nor in place of not. So if not, let's try to run again and check. Cannot import the, okay, again the typo mistake, where it is, see, we have made a typo mistake. Default dict, here we have written right now. Okay, let's try to run it again, check it. Okay, so now we are getting wrong answer. Let's try to debug this. Why is it happening? So we have taken length of the ARR correctly, then we have defined a dictionary as default dict of list. Okay, and we have not marked, suppose if length is equal to 1, if length is equal to 1, we have to simply return 0. So this thing we should do that at the top step only, do not go down. Now we let's check for I comma val in enumerate ARR. We are appending all the indexes. Okay, correct. Now we are initializing queue with just adding the first index and marking visited as okay, and step 0, this also seems correct. Then we are traversing, so while queue for range lane of queue I is equal to q dot pop left, that also correct, seems correct. So if I is equal to n minus 1, return steps. Okay, and then we are defining neighbor. If I minus 1 is greater than equal to 0, neighbor dot append. Oh, see, we are again appending here. We should have appended I minus 1, right? And here we should have appended I plus 1. Okay, and now check furthermore if there is any more wrong. So what we are doing, neighbor dot extend, we are one of you just extending it, correct, seems correct. So for neighbor in neighbor, if not visited neighbor, we are marking it as visited, means true, and then we are appending that in our queue, and then we are simply incrementing the steps after each level traversal, and finally returning -1. Okay, so I think this was only the error I minus 1 I plus. We should have appended the other index. We forgot to just append the, we just appended the same index. Okay, so let's try to run and check if this works this time. Yeah, so our test cases has passed. Let's try to submit and check. Okay, it's taking time. It's giving TLE. Wow, how can it give TLE? Okay, so what we are doing now, suppose why it's giving TLE, we have created a default dictionary. Okay, now we are showing 100, it has 2 positions. So what we have to do, these paths have been tracked. So when we are coming out of this, marking each neighbor and appending that, what should we do? We should always clear the dictionary list. Okay, so what we will do, simply clear it, tick one of ARR of I. Okay, now just clear it, clear the list, so it will not give TLE, it will not go into the infinite loop. So let's try to run and check again. Test cases are again passed. Let's try to submit and check. Hope this works this time. Yeah, so our code has passed successfully. Thank you for watching. There was only one issue, we were not clearing the dict after traversing it. So okay, thank you.